Welcome viewers. In this video we will see the details about duality and dual network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Details about duality and dual network. There is a parallelism between the loop equation and the node equation of a network. So there is a relation is available. Only the symbols are interchanged. The symbols, the voltage E or resistance R and current. The voltage E or V, resistance or impedance and current in loop equation are replaced by the voltage E or V is replaced by I. Resistor R is replaced by conductance. Impedance is replaced by admittance. Similarly, I is replaced by voltage E or V. So all are interchanged respectively in the model equation, right? So E or I is replaced by I, G and E. That is called a dual network. The two networks are called dual network if the mesh equation of one have the same form as the model equation of the other, right? So then it is called a dual network, right? Now we'll see the further details. The property of the dual network. The property of duality is a mutual property. If the network, what is that mutual property? If network A is dual network of B, then the network B is also the dual network of A, right? So the A is dual of B means B also dual of the A. That is called a mutual property. For two networks to be dual, it is necessary that the variables and elements of one network should also be the dual of the variable and elements of the other network, right? So what are the variables elements available in the first network? That should be the dual of the all the variables and elements in the other network. So the variables and elements are available in network 1 as well as network 2 also. Since messy currents are applicable to planar networks only, these network will have duals. So the planar network having the dual network, that is applicable for the planar network. Then what about the non-planar network? The non-planar network do not have dualities. Only the planar network we can have duality. Some of the dual pairs are given in the following table. Now we will see what are the dual pairs available in the electrical network. Now we will see the tabular column. So this is the original network. First column original network, second one dual network. So for the current, the dual network is voltage. For voltage, dual network is current. Similarly, source current means source voltage. Source voltage means source current. Mesh current means node voltage means mesh current. Open circuit means short circuit means open circuit. Resistance means conductance. Inductance means capacitance means inductance. Similarly, series branch means parallel branch means series branch. Impedance means admittance. Reactance means susceptance. KCL means KVL. Kirchhoff's current law means Kirchhoff's voltage law. So these are all the original and the corresponding dual networks. The tabular column is available. Now we'll see the further details. The principle of duality is very useful in the sense that solution of any network gives the solution to the dual. So if you want to find the solution of the network means the same thing can be obtained from the solution of the dual network also, right? So in such case, for these three circuit elements R, L and C, resistor, inductor and capacitor, the duality is shown below, right? So for V equal to I into R, the voltage across the resistor is a normal Ohm's law, V equal to I into R. The same thing can be written as I equal to G into V, right? G is nothing but conductance. Here resistance, here conductance. Here we are calculating the voltage, here we are calculating the current. So V equal to IR, very basic formula, Ohm's law. Here I equal to V by R normally, but 1 by R is in a conductance. So G into V. Similarly, the voltage across the inductor VL equal to L DIL by dt. The same thing in the duality we have IC. Here voltage across inductor means current through the capacitor. C dVc by dt. Right? The current IC equal to C into dVc divided by dt. Right? Here calculating voltage, here current. Similarly, the voltage across the capacitor Vc equal to 1 by C integral IC dt. So these are all the original circuit, what we know very well. Voltage across resistor is I into R. Voltage across inductor L dIL by dt. Voltage across capacitor 1 by C integral I dt, IC dt. Right. Here R is replaced by conductance. Resistor is replaced by conductance. Similarly, voltage, here current, it is C dVc by dt. Here L, here C. Similarly, voltage across capacitor, here current through the inductor 1 by L integral VL dVL into dt. See here the C is replaced by L, I is replaced by V. Current through the capacitor, here current voltage across the inductor. Similarly, here L is replaced by C, I is replaced by V. Right? So this is the dual of the basic elements resistor, inductor and capacitor. So in this video we discuss what is mean by dual network, what is the duality, what are the properties available, and we discuss the tabular column of the original network, what is the dual network, and also basic three elements, duality of the three element resistor, inductor and capacitor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the method of drawing the dual of a network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. What is the method to draw the dual of a network? We know that original network, from that we can draw the dual network, duality. The following steps are followed to draw the dual of a given electrical network. The first one is a dot is placed in each independent loop of the original network. These dots placed inside the loop corresponding to the independent nodes in the dual network. So the first step is we need to identify what are the loops available. For every loop we need to place the dot inside the circuit. We need to place the dot for every individual loop. That is very similar to the node in the dual network. Right. So the next step, second step is a dot is placed outside the given network. This corresponds to the reference node of the dual network. So for every loop we place the dot inside the network. One dot is placed outside the network, that is called a reference node of the dual network. All the dots are connected by the dotted lines crossing all the branches. Now we need to connect all the dots. That is by the dotted line that is going through the branches. That is either resistor, capacitor or voltage sources. Right? So the dots are connected by the dotted line through the branches, through the elements. The dotted lines should cross only one branch at a time. So for example, if the resistor and voltage source available means we need to draw separate line for voltage source, separate line for resistor. Only one element should cross. The dual elements will form the branches connecting the corresponding nodes in the dual network. Right? So the dual elements. So while crossing that, the resistor means the dual element, conductance should be there. Inductor means capacitor. Capacitor means inductor. Voltage source means current source. So the corresponding nodes in the dual network, that is given. So while connecting the dots through the element, we need to find the dual of that network. So that dotted lines is nothing but a dual of a original network. We need to draw the dual network separately. So there are two nodes available. One is the voltage rise in the clockwise direction correspond to a current flowing towards the independent of the network. Right? The voltage rise in clockwise direction. A clockwise direction in the loop correspond to the positive polarity at the dual of independent node. So we need to see the polarity, whether it is rising polarity or falling polarity. Rising means the current will also going upward. The polarity is falling means the current will go downwards, right? So accordingly we need to identify. Now we'll see the example problem. So in this example problem, this is a given network. Network is available. So the two voltage sources available, 5 voltage and 10 voltage. Then 3 resistor, 3 ohm, 4 ohm and 7 ohm. So we have 2 loops available. We know that loop is nothing but a closed path. This is one loop. Is the current flowing through the first loop is I1. Similarly, this is another loop. The current flowing through the loop is I2. Right? So the first step we need to identify how many loops are available. Now we can go to the dual network. We will follow the procedure given by the dual network. So this is the diagram is drawn again. The black color diagram is the original network. The first step is we need to place the dot in each and every loop. So this is first loop. We placed one dot and numbered as 1. This is another loop. Here one more dot is placed, numbered as 2. So we have 2 loops available. So 2 dots are placed, numbered as 1 and 2. And one dot is placed outside the loop. This is called a reference node. This is called reference node, right? So what is the next step? We need to connect all the dots, right? First we will connect the dot 1 and dot 2 through the resistor 7 ohm, right? Through the resistor 7 ohm on the dotted lines. The dot 1 and 2 is connected by the dot line through the 7 ohm resistor. Only in between 1 and 2 only 7 ohm resistor is available. So this 7 ohm resistor now will convert it into 7 conductance, right? So that is connected between 1 and 2, right? Now we'll see 1 and 0. What are the terms available connected between 1 and 0? So this voltage source is connected and also the resistor is connected. Two elements are connected between 0 and 1, right? So this is the element 0. So I already know that only in the dotted lines only one element should be there. If two elements are there, mean you have to draw the separate dotted lines, right? So this line connecting the node 1 and 0 through the voltage source. This line connecting the node 1 and 0 through the 3 ohm resistor. So 3 ohm resistor will be converted into 3 conductance that is connected between 1 and 2. Similarly, 5 voltage source is converted into 5 ampere current source, right? Rising polarity. What is the rising polarity? See the current direction. Current is flowing in clockwise direction. See this, it is going from negative terminal to positive terminal. So negative to positive means voltage rise, right? So the current is flowing like this. So like this means it is flowing from negative to positive. Rise in polarity, right? Negative to positive, rise in polarity. So that the current source also 5 ampere rise in polarity, right? So between 1 and 0 voltage source is there, that is converted into current source. 3 ohm resistor, that is converted into 3 ohm, 3 conductance, that is 1 and 2. Now we'll see 0, 2 and 0. What are the terms available between 2 and 0? So here also one more voltage source is available and one resistor available between the dot 2 and 0. So this line connecting the dot 2 to the dot 0 through the voltage source. This line connecting the dot 2 with the dot 0 with 4 ohm resistor. So this 4 ohm resistor will be converted into 4 mho conductance connected between 2 and 0. Now see the polarity of current. See the current is flowing, same thing. Current is flowing in clockwise direction but is flowing from positive terminal to negative terminal, right? Positive terminal to negative terminal. So the fall in current. So the voltage current source is going down, right? Connected between 2 and 0. So here current is rising, negative to positive. Here current is flowing positive to negative. So that fall in potential, current also going in the downward direction, right? So see this 7 ohm converted into 7 more conductance connected between 1 and 2. 3 ohm converted into 3 more connected between 1 and 0. 4 ohm converted into 4 more conductance connected between 2 and 0. This 5 voltage connected between 1 and 0 converted into 5 ampere current source with going upward direction. This 10 voltage source converted into 10 ampere current source going down because the current is flow from positive to negative. So based on that, we'll see the dual network. So this is the dual network. Between 1 and 2, 7 more conductance is there. Between 1 and 0, this 3 more conductance and also 5 ampere current source going rising current. Between 2 and 0, 4 more conductance and 10 ampere current source going down, right? So 1 and 2, this one resistor. Between 1 and 0, one resistor and current source. Between 2 and 0, one more resistor and the another current source. So this is the dual of the network, dual of the given network. Now we'll see the description. Description is available. What we did, the sentences are available. We'll see that. So the description is, inside the loop 1 and 2 of the given network, dots are placed and named as 1 and 2. Outside the loop, the dot is kept and named as 0. The dot named as 1 and 2 are joined by the dotted line through the 7 ohm resistor, so that it will be converted into 7 more conductance. Dot 1 is joined to dot 0 through the dotted lines. One is crossing the 3 ohm resistor, another one crossing the 5 voltage source. Another one is crossing the 5 voltage source. So that this 3 ohm is converted into 3 more conductance. 5 voltage source is converted into 5 ampere current source going in a upward direction, right? Another dot 2, another dot is dot 2 and 0. Dot 2 is joined to dot 0 through the dotted lines. One is through the 4 ohm resistor, another one through the 10 voltage source. So that this 4 ohm resistor is converted into 4 more conductance. 10 voltage source is converted into 10 ampere current source going down because of falling potential. The dots are placed on the paper. They are connected by the dual network to obtain the connected dual elements to obtain the dual network. So the dots 1, 2, 0 is placed in a paper. Between 1 and 2, one resistor is connected. Between 1 and 0, resistor and one current source is connected. Between 2 and 0, another resistor and current source is connected. So that is given here. So the note is there. There is no change of numerical values. There is no change. Numerical values are same. 7 ohm is means 7 more conductance. Both are value same. 5 ampere. 5 voltage means current. 5 voltage source means the current source also 5 ampere. Same thing. Resistor become conductance. Source voltages become source currents. So in this video, we'll see how to draw the dual network. What is the procedure available? And we discussed one example problem. And for example problem, what is the description? That also we discussed the description also. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the solved problem based on the dual network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Draw the dual network for the given network shown below. So this is the network given. For that we need to draw the dual network. So 20 voltage source available. Inductor 10 Henry. Resistor 2 resistor 3 ohm, 6 ohm and one capacitor 5 farad. For that we need to draw the dual circuit. The step 1 is we need to put the dot for the every loop in the circuit. So first we will identify what are the loops available. So this is the loop 1. First loop. Loop is nothing but closed circuit. This is the second loop. So we need to put the dot for first loop as well as the second loop. Now we'll go to the diagram. So this is the dual network diagram. So for the first loop, dot is placed and numbered as 1. For the second loop, one more dot is placed, numbered as 2. So 2 dots are available, 1 and 2. And one more dot is placed outside the loop. That is called 0 as a reference loop. So the step 1 is put the dot for every loop, and second step is put the dot outside the network called a reference node. Now we need to connect all the dots. First we will connect the dot 1 and 2 through the 3 ohm resistor. So between 1 and 2, 3 ohm resistor connected. So it is connected by the dotted line. This is nothing but a dual network. Now this 3 ohm is converted into 3 mho conductance. Resistance now converted into conductance. Ohm converted to mho. It is connected between loop 1 and the dot 1 and 2. Now we'll see the elements available between dot 1 and 0. There are 20 voltage source available between 1 and 0 and 10 Henry inductance available between 1 and 0. We need to draw the separate dotted lines through the voltage source as well as the inductor. First we will see the voltage source. So the dotted line is drawn between 1 and 0 through the voltage source, 20 voltage source. Now this 20 voltage source will convert it into 20 ampere current source. So this is available. 20 ampere current source. 20 voltage source is converted into 20 ampere current source that is connected between 1 and 0. And now we'll connect the 1 and 0 through the inductor, 10 ohm, 10 Henry inductor, right? So this 10 Henry inductor. Now this 10 Henry inductor will convert it into 10 farad capacitor. So this 10 Henry converted into 10 farad capacitor that is connected between 1 and 0. Now we'll see what are the elements connected between 2 and 0. There are two elements connected. One is resistor 6 ohm and capacitor 5 ohm. First we will draw the dotted line between 2 and 0 through the resistor 6 ohm. So this 6 ohm will be converted into 6 mho conductance that is connected between 2 and 0. And draw one more line through the 5 farad capacitor between 2 and 0. Now this 5 farad capacitor will be converted into 5 Henry inductor is connected between 2 and 0. So this black color line is the original network. Red color lines are known as the dual network. Now we need to draw the dual network based on the analysis what we did. So for that we have to put the 3 dotted lines 1, 2 and 0. Then we'll connect all the elements. Between 1 and 2 this 3 mho conductance. 1 and 0 20 ampere current source, 10 farad capacitor. Between 2 and 0 6 mho conductance, 5 Henry inductance. Like that we need to connect. So first we will put so this is the dual network. So 3 dots are placed. First 3 dots 1, 2 and 0. Between 1 and 2 3 mho conductance. Between 1 and 0 10 farad capacitor and 20 ampere current source. Between 2 and 0 5 Henry inductance and 6 mho conductance. So this current is going upward because the voltage is rise in voltage. That also we need to find. See, the current is flowing in the clockwise direction. So it is going from negative to positive. That is rise in potential. So due to that the current source also rising. The current source also going upward direction. So in this video we discussed how to draw the dual network from the given original network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the solved problem based on the dual network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to draw the dual network for the network shown below. So this is the given network. We need to identify the number of loops. The step 1 is we need to place the dot in the loop, every loop. So this is the first loop. Loop is nothing but closed circuit. This is the second loop. The current is flowing, we are assuming, in clockwise direction. Current is flowing in clockwise direction. So here one dot is placed, named numbered as 1. Here one more dot is placed, numbered as 2. So 2 loops are there, 2 dots are placed. One dot is placed outside the network, that is called 0, numbered as 0 is a reference node. It's a reference node. Second step is we need to connect all the dots. First we will connect the dot 1 and 2 through the elements. Now by the dotted lines. Now the dotted lines are drawn between 1 and 2 through the 2 ohm resistor. What will happen? This 2 ohm resistor will be converted into 2 more conductance. So between 1 and 2, 2 ohm resistor will converted into 2 more conductance. Now we'll connect dot 1 and 0. Between 1 and 0, 2 elements are available. One is voltage source, another one is inductor. So that draw the dotted line between 1 and 0 through the voltage source. Now this voltage source will converted into current source with 10 ampere. Whether it is rising or falling, that is done by this current direction. See the current direction, current is flowing in clockwise direction, that is from negative to positive. So rise in potential. So the voltage also, so the current source also going upward direction, right? The current is flowing from the negative polarity to positive polarity. Negative to positive means rise in potential. So the current also going in upward direction. And draw the dotted line between 1 and 0 through the 5 Henry inductance. So this 5 Henry inductance will be converted into 5 Farad capacitor. Right. Now we'll connect the dotted line between 2 and 0. Here 2 elements available. One is resistor, another one capacitor. Now draw the dotted line between 2 and 0 through the resistor. So what will happen? This 0.5 resistor will convert it into 0.5 mho conductance. Draw one more dotted line through the capacitor between 2 and 0. So what will happen? This 2.5 farad capacitor will convert it into 2.5 Henry inductor. Now all the dots are connected together and also converted. Now we can draw the dual network. So this is the conversion between 1 and 2, 2 ohm resistor converted into 2 more conductance. Between 1 and 0, 10 ampere, 10 voltage source converted into 10 ampere current source. Between 1 and 0, 5 Henry inductance converted into 5 Farad capacitance. Between 2 and 0, 0.5 ohm is converted into 0.5 mho conductance. Between 2 and 0, 2.5 Farad capacitor converted into 2.5 Henry inductor. Now we'll see the dual network. So this is the dual network for the given network. We have to put the dots first. 1, 2 and 0. We have to place the 3 dots. Between 1 and 2, what we have? This 2 more conductance. So between 1 and 2, 2 more conductance is drawn. Between 1 and 0, 2 elements available. One is current source, another one capacitor. So the current source is drawn here. Between 1 and 0, current source 10 ampere going upward direction because of rise in potential. One more element between 1 and 0 is capacitor, 5 Farad capacitor. Then 2 and 0, the 2 elements are available. 0.5 mho conductance, then 2.5 Henry inductor. So this 2.5 inductor is connected. So this is 0.5 mho conductance is connected, right? So between 1 and 2 we have one conductance. Between 1 and 0, volt current source and one capacitor. Between 2 and 0, inductor and one conductance. So this is the dual of a given network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the dual network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to draw the dual network for the network shown below. So this is the network given. Here 100 voltage source is available. Capacitor, resistor and inductors are connected together. We need to draw the dual network for this given network. First we need to identify the loops. We need to place the dot for the every loop. So this is this is the first loop. Loop is nothing but closed path. So the current is flowing through voltage source and capacitor. This is one closed path. This is another closed path. Resistor, inductor and capacitor. So here one dot is placed, numbered as 1. Here one more dot is placed, numbered as 2. The loop 1, loop 2. Outside the network one more dot is placed, that is numbered as 0. This is a reference node. So the first step, you have to put the dot in every loop, one more dot in the outside. So we have 3 dots, 1, 2 and 0. Now we need to connect all the dots. First we will connect dot 1 and dot 2 through the elements. So here 1 and 2 is connected through the capacitor, 10 microfarad capacitor. So this capacitor will convert it into inductor, 10 microhenry inductor in the dual network. This black color is the original network, red color is the dual network. Right? So 1 and 2 is connected through the capacitor, so that will be converted into inductor. Now between 2 and 0, what we have, 10 ohm in resistor is available. That will be converted into 10 mho conductance. Right, between 2 and 0. Then we will see the 2 and 0. One more element is available. This inductor. Between 2 and 0, one more element, inductor, this connected by the dotted lines. So that inductor will convert it into capacitor. 0.1 Henry inductor converted into 0.1 Farad capacitor. So between 1 and 2, capacitor is there, that will be converted into inductor. Between 2 and 0, 2 elements are available. One is resistor 10 ohm, that will be converted into 10 mho conductance. 0.1 Henry inductor, that converted into 0.1 Farad capacitor. Now between 1 and 0, what we have, one voltage source is available. That is now converted into 10 ampere current source. Right? Voltage source now converted into current source. See the direction of current. Current is flowing in clockwise direction. That is from negative to positive. Current is from negative to positive. So the rise in potential. So the voltage also rising, going upward. The current also going upward direction. Right. So now all the elements are converted. Black color lines are original network, red color lines are dual network. Now we'll see again. Between 1 and 2 we have inductor. Between 2 and 0, one conductance and one capacitor. Between 1 and 0, one voltage source, one current source. Right. Now we need to draw the dual network. First step, we have to put the dots. In a plain paper we have to put the dots. There we have 3 dots, 1, 2 and 0. So between 1 and 2, what we discussed, 10 microhenry inductor is there. Right. Between 1 and 0, one voltage source, rise in voltage, because current is flowing negative to positive terminal. Between 2 and 0, 10 mho conductance and 0.1 Farad capacitor. Right. So the dual network is drawn by put the dots, 3 dots, then connect the dots. 1 and 2 connected with inductor. 1 and 0 connected with voltage source. 2 and 0 connected with one conductance and one capacitor. So this is the dual network of the given network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the solved problem in the dual network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Draw the dual network for the following network given. So this is the network given in the problem. We need to draw the dual network. This black color is the original network. The red color is the dual network. So here we have the current source available. Resistor, inductor, capacitor are connected in parallel. So the step 1 is we need to put the dot in the every loop. We need to identify the loop. In every loop we have to put the dot. So here 3 loops are available. This is the first loop, current source and the resistor, current flowing through this. This is loop is nothing but a closed circuit. This is the second loop, resistor and inductor, current is flowing through the resistor and inductor. This is the third loop, inductor and capacitor. So 3 loops are available. So here the dot is placed in the first loop and is numbered as 1. Another dot is placed in second loop, is number 2, and dot is placed in third loop, numbered as 3. So 3 dots are available as 3 loops, and one more dot is placed outside the network, that's 0, numbered as 0. This is a reference node. This is a reference node. So the step 1 is every loop we have to put the dot, and one more dot is placed outside the loop, that is a reference loop, reference node. Now we need to connect all the dots. First we will connect dot 1 and 2 through the elements. So the dotted lines are drawn between the point 1 and dot 1 and dot 2. They are crossing through the resistor. So this resistor will be converted into conductance. Resistance will be converted into conductance G. So dot 1 and 2 is connected, through which we have resistor that is converted into conductance. And dot 2 and 3, the dotted lines are drawn between dot 2 and 3 through the inductor. So this inductor will be converted as a capacitor. L is converted to capacitor C. Then 3 and 0. 3 and 0 we have capacitor. The dotted lines are drawn between point 3 and 0 through the capacitor. So this capacitor will be converted into inductor in the dual network. Right. Now 1 and 0, we have the current source is available. Right. So the current source is available through that. So 1 and 0 is connected. So this current source will be converted into voltage source. Right. Now see the current direction. Current is going upward. So this end is positive and this end is negative. Right. So 1 and 2 resistor converted into conductance. 2 and 3 inductor converted into capacitor. 3 and 0 capacitor converted into inductor. 1 and 0 current source converted into voltage source. Now this red color line is nothing but the dual network. Black color is the normal original network. Now we'll draw the dual network separately. So what we need to do, we have to put the dots in a paper. 1, 2, 3 and 0. We have to put the 3 dots. Between 1 and 2 we have conductance G. 2 and 3 capacitor C. 3 and 0 inductor L. 1 and 0 voltage source V. Now we need to connect all the elements. So in original network, resistor, inductor, capacitor connected in parallel. In dual network, conductance, capacitor and inductor connected in series. Voltage, their current source converted into voltage source. So this is the dual network for the given original network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the dual network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to draw the dual network for the network shown in the diagram. So this is the given network. So the voltage source available, resistor, inductor and capacitors are connected in series. We need to convert this network into dual network. So the first one is we need to see how many loops are available. Loop is nothing but a closed path. So here only one loop is available. Current is flowing through the voltage source, resistor, inductor and capacitor. Only one loop is available. So we need to put the dot in the loop. Right? So this is dot is placed and numbered as 1. So the dot is placed in each and every loop. Here only one loop is available. So one dot is placed. And one more dot should be placed outside the loop, outside the network, 0. This is called a reference node. This is a reference node. Now we need to connect all the dots. Here only 2 dots available. So we need to connect the dot 1 with the dot 0. Right? So first step, loop is identified. Every loop we have to put the dot. Here only one loop is available, so one dot is placed and one more dot is placed outside. Now we need to connect the dot. So the 1 is connected with 0. While connecting 1 with 0, there are 4 elements available. So this line connecting, this dotted line connect the dot 1 through the resistor. So that resistor will be converted into conductance in a dual network. This dot 1 is connected to the dot 0 through the inductor. So that this inductor is converted into capacitor C. This dot 1 is connected through the capacitor. So this capacitor will be converted into inductor. And dot 1 is connected through the voltage source to the dot 0. So the voltage source will be converted into current source. Right? So between 1 and 0 only 2 dots available. So we need to connect 1 and 0. But each and every element separately we need to connect. So 1 is connected through resistor converted into conductance. 1 is connected to the 0 through inductor converted into capacitor. 1 is connected to the 0 through capacitor converted into inductor. 1 is connected to 0 through the voltage source, that is converted into current source. So this red color line is a dual network. Black color line is a original network. Now we'll draw the dual network separately. So this is the dual network. So in a paper we have to put the dots. Here 2 dots are available, dot 1 and dot 0. Now we need to connect all the elements. So between 1 and 0, 4 elements are available. That is the conductance, capacitor, inductor. All three are connected in parallel. It is clearly given in the previous diagram. These red color lines are parallel. On other side, the current source is connected. Between 1 and 2, current source is connected. Right? Now we will refer the dual network again. So it is very clear. So between 1 and 0, current source is connected. This side between 1 and 0, these 3 elements are connected in parallel. Conductance, capacitance and inductor. So that is given in the separate diagram. These 3 are connected in parallel, and other side current source is connected. So in this video we discussed the solved problem in the dual network. How to draw the dual network from the original network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the dual network. Subscribe this channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to draw the dual network for the network shown in the diagram. So first we need to identify how many loops are available. Loop is nothing but a closed path. So this is the loop 1. The current is flowing through the voltage source, inductor and resistor, one loop. This is the another loop. Current is flowing through the capacitor and these 2 resistors. So there are 2 loops are available. So the step 1 is we need to put the dot in the each and every loop. Now we'll refer the another diagram having the dots. So the 2 loops are available. This is loop 1, loop 2. Step 1 is put the dot in each and every loop. So here one dot is placed and numbered as 1. Here one more dot is placed, numbered as 2. So this is refers the first loop, dot 1, second loop, dot 2. And one more dot is placed outside the network. This number as 0. This is called a reference node. Right? So number 1, 2, 0. 3 dots are available. These 2 dots based on the number of loop. One dot is the reference node. Now we need to connect all the dots. All the dots are connected through the element, circuit element. First we will connect the dot 1 and 2 through this resistor. So the 1 and 2 is connected through the resistor. So this 3 ohm resistor will be converted into 3 more conductance. So between 1 and 2, 3 ohm resistor will be converted into 3 more conductance. Right. Now we'll see the 2 and 0. 2 and 0, 2 elements are available. First 2 and 0 is connected through the 6 ohm resistor. This 6 ohm resistor will be converted into 6 more conductance between 2 and 0. Between 2 and 0, one more element is a capacitor. So between 2 and 0, this dotted lines connected through the capacitor. So this capacitor will convert it into inductor. 5 farad capacitor will convert into 5 Henry inductor between 2 and 0. So between 2 and 0, two elements are available. 6 ohm resistor converted into 6 mho conductance. 5 farad capacitor converted into 5 Henry inductance. Now we'll see the 1 and 0. In 1 and 0 also two elements available. One is inductor, another one is the voltage source. First we'll connect the 1 and 0 through the voltage source, so that this 20 voltage will be converted into 20 ampere between 1 and 0. See the current direction. The current is flowing as a clockwise direction. So the current is flowing from negative terminal to positive terminal. That is called a rise in potential. So the current also going upward direction. Suppose the current is flowing from plus to minus means fall in potential. So current will go downward direction in current source. But in now the current is flowing from negative terminal to positive. So the rise in potential, so that voltage source also going in a upward direction. And now we'll connect the 1 and 0 through this inductor, so that this 10 Henry inductor will be converted into 10 farad capacitor. So this 10 Henry inductor converted into 10 farad capacitor between 1 and 2. And also the voltage source converted into current source. Now all the elements are converted. Now we can draw the dual network. So point dot 1, dot 2 and dot 3, dot 0 are available. Then how to draw the dual network? We have to put the dots in a plain paper. 1, 2, 3. 3 dots are placed. Now we can connect the dots. Between 1 and 2, 3 more conductance is available. Between 1 and 0, two elements available. One is current source, 20 ampere. Is rise in current. The current is going upward because of rise in voltage. So the current also going upward direction. And one more element, 10 farad capacitor. Between 2 and 0, two elements available. One is 6 mho conductance. Another one 5 Henry inductance. Right? So here voltage source converted into current source. Resistor converted into conductance. Capacitor converted into inductor. Inductor converted into capacitor. If it is connected in series, means connected in parallel. 3 more resistor connected in across, now connected in series. These are all connected in series, now connected in parallel. So this is the dual network for the given original network. So subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.